Number 3, were there any significant differences between the Dunstown University students and the Sussex University students in the DVs of exam, computer scores, lectures, and numeracy? Okay, so that's an independent t-test because you got two separate groups. You got Sussex and Dunstown. So we're going to go to Analyze, Compare Means. That's what a t-test does, and this one is an independent samples, also known as a two-way or a two-sample. And so we're going to stick all our DVs in there, and I forgot what they were. Please hold. Oh yeah, the big 4, right? Okay, so we're going to stick, these are our DV dependent variables. This is what's physically being measured in everybody in the study. That's what a DV is. And our grouper, our grouping DV, our partitioner, is the university, right? And it's marked 1 and 2. Let me show you what that means. Click OK. Right, 1 and 2. Let me show you what that means. Okay, 1 and 2. That is this right here, right? 1 is the Sussex University, 2 is the Dunstan. All right, and then we just go ahead and look at the output. So here are the group means for each one. Exam, there's Sussex, 61.7. Exam, Dunstan, 54. Computer, Sussex, 51. Computer, Dunstan, 50. So these are the actual means, and down here are the tests. Very important, this first test right here, where it says Levine's test, these first 1, 2, 3, 4 columns are about the Levine's test. So the Levine's test measures the assumption of homogeneity of variance. That means that the variance between the little groups is roughly the same. So this first one, for the exam scores, the variance in the exam scores for the Sussex students is relatively the same as the variance in the exam scores for the Dunstown students. If this number was less than 0.05, that would have been violated, and you can see down here that for numeracy, it was violated. In other words, the variance between the two schools for their numeracy scores was not similar, so it violated that assumption. So, but now we're going to look at the t-test, and if the variances were assumed, which that means if they weren't violated, you use the top row. If they were violated, you use the bottom row. But we're going to look right here. So the sig two-tailed is not less than 0.05. Now, if we picked a side, if we said Sussex was going to do higher, that would have made it a one-tailed. We'd have to divide that by 2, and it would have been significant. But since we didn't say that, we just said if there's a difference, that makes it a two-tail. And it's not less than 0.05, therefore not significant. Computer literacy, same thing, not less than 0.05, not significant. Lectures, not less than 0.05, not significant. But the numeracy, yes, there was a significant difference between the Sussex and the Dunstown students when it comes to numeracy. So once you get significance, you go back up here and you see who's significantly higher. So Sussex was significantly higher in their numeracy scores than the Dunstown guys. And that's it. But remember, a t-test, independent t-test, has 3 assumptions. One is normality. And we already know that the only one normal here is lectures. So numeracy violated the assumption of normality, and it violated the assumption of homogeneity variance. The third one is independence of observation. There's no way to check that assumption. We just assume it's true. But you would not, in the real world, you would not run the independent t-test for numeracy because it violated 2 very important assumptions. So that's it. MGZ out.